So in general, you will hear this word anyone tell me what this is? Rectilinear motion. It is a motion in a straight line. We could also have a circular motion, and that is a motion in a circular path. Can we have a constant velocity motion in a straight line? Yes, we absolutely could. Could we have a constant velocity motion in a circular path, even if it's going with a constant speed? No, there is no way for any object to go in a circular path and be a constant velocity. It could have a constant speed, yes, but it can never be constant velocity. Why? Because it is changing direction and it is always accelerating towards the center, right? That's why we call it centripetal acceleration, centripetal motion. Now, what is the most simplest kind of motion that we know of? The most simplest kind of motion that we know of is a motion where acceleration is a constant. It could be a positive acceleration, it could be a negative acceleration, but a constant acceleration problems are the most simple ones. That is what we have been doing in Intro 1. So if you remember drawing the graphs from Intro 1, what would the graphs look like? If I have a time versus X graph, it either went like this. Do you remember drawing these graphs? There was a TV graph, and then there was a TA graph. If this is a constant graph moving upwards, what's the corresponding velocity for this graph? It's just a straight line, correct? And what's the acceleration in this case? 0. Good? So now what's the next graph that we are aware of? If you have an accelerated motion, what do these graphs look like? So I'm not telling you guys anything new, right? Is this a surprise for anybody? Okay, so just making sure. So X graph looks like what? X goes up. As time goes by, we're covering more and more distance. What does the velocity versus time graph look like? And what does the acceleration graph look like? Flat, but it has a value. Everybody knows that, right? This is not a surprise to anybody? Okay, excellent. And then we have all of those other alternatives, right? If the ball is falling down, the graphs are going to flip and all of that, right? And if you're slowing down, the graph will go quickly down for X and then negative velocities and all of that fun stuff, right? So we are all aware of those graphs and how they change. It's basic Intro 1 problems, nothing complicated, right, bobbleheads? Yes? Now, so I'm going to start with equations of motion. We're going to derive them. Again, this is just revision, so hopefully this will go really fast. What is the basic definition of acceleration? The rate of change in velocity. When I say a rate of change of something, what is that in math? Well, either of you. True, but what's the important part? Derivative with respect to? Excellent. That's what it means. When I say the rate of change of something, then I mean the change with respect to time. So if I say acceleration, anybody want to write the formula down in math now? Did everybody get something like this? And then Corey, what did you say? It's the initial minus the Oh, Sylvan, you said initial, what, can you repeat what you just said?
Said initial, finalized versus defined initial.
Good. That means we have to look at what they're called starts with a B, boundary conditions. Very good. These words are important. And so now we have to define our boundary conditions. We have a few things we are going to define because we're going to talk about a motion that goes from point A to point B. So what kind of boundary conditions do you think I should define for these? Good. Starting at rest. What would you like to call rest? X0? And ending at final? XF? Everybody okay? Does anybody want to call it XI initial? That's fine too. It's up to you, whatever you feel comfortable with. I tend to do X0s, but if anybody wants to do I's, that's fine with me. Okay. And then what's the change in between X0 and X final? Delta X. And then what else do you think we should do? Good. And at T final, what else should I define? What about V0? So it has to have some instant velocity and some final velocity, correct? And we're going to talk about the simplest motion, which was when acceleration is a, very good, acceleration is a constant for my motion. So now our task today is to find V as a function of time and A as a function of time and X as a function of time. We have to set up equations that do that. And the way we're going to do it is by knowing just a very simple A equals dV over dt and doing a bit of calculus. Everybody okay? Can I do that? Can I do that? Is A constant? Can I take it out of the integration? Okay. So would this be written as A dt dV? My limits of integrations will be? Good. On my right side, will I get? Is that an equation I will develop?
Yes.
Okay. So in general, you will see this equation written as 4 we have all seen this equation, right? Yeah. Why am I allowed to write this equation and drop the subscripts of t's? There is only one condition where this is allowed. And that condition is when T0 is taken to be 0. When we start, everybody understands the difference between T0 and when T equals 0, right? Okay. What time did this class start? What time is it now? 11:20-ish. How much time has passed between the class starting and now? If you take 10 a.m. as 0, then what's the time right now? Make sense? Yes. So in our situation, I've rewritten equation 1 again. Can I drop this because I don't necessarily need to know V final, right? We're going to develop it. But is V0 a constant number? Because that was our initial boundary condition. We can't change that. Okay. So now, can I write this as dx over dt? Can I move the dt over to the other side? So I can rewrite this equation. Should probably remind myself to do that. Now may I integrate? Limits of integration on the left side. And then this one is from T0 to T. Okay, so when I integrate this, what do I get? Everybody understands these integrations, right?
Yes.
So I don't have to. So in general, you will see this equation written as and this is only allowed in the situation where T0 is, and you have seen this many times in your life. Yes?
Yeah.
Do you guys want to do the last one now? I see a lot of hands. Okay, so the last one is the fun one. And we've done this a bunch of times, so you guys are familiar with this. So A equals dV over dt. I do this. No objection so far? I combine these. So I will get, this implies A equals V dV over dx. So this implies I can write A dx equals V dV. Yes. Good. Okay, keep going. Now I can integrate. So now take a second. Think about the limits of integrations. Don't say it. Write them down. What will be the limits of integration? 0 to V. So this implies I can write this equation as A x x0 to x equals V squared over 2 from V0 to V. What do I get? A delta x equals V f squared over 2 minus V naught squared over 2. 2 can go to the other side. And we have seen this equation a bunch of times. This is number 3.